All right, welcome back. So we're going to look at participant number 26, and it's going to be the same process, but after that we're going to tackle this one right here. This is more conceptual, and then we're going to move on to question number 3. So looking at this data set again, if we were to move this over, and all I'm doing is highlighting the entire section and then just dragging it over to this section. Move down to participant number 26. And if I was to move over just a little bit to participant number 26, we're going to look at the Z pre-weight and the raw pre-weight, the unstandardized and the standardized. We see this raw score of 182.60 and a pre-weight of 1.29738 or 739. So we're going to go into here and just see how it's written out. And this is kind of how I wrote it out. You might have a slight variety of this in your own report, but you want to italicize the Z here, and I forgot to mention that in the last video. So at any rate, we're just going to copy down this information here. So the 26th participant had a raw score of 182.6, and then their Z score is going to be 129. Actually, if we round this up, the 7 is going to make this into a 9, a 10, so this is going to be 1.3. So this is going to be 1.3 standard deviation, or a Z-score of 1.3. This Z-score indicates that the 26th participant pre-weight score was above, because it's a positive number, above average at a value of 1.3 standard deviations. All right, so what does this all mean? If I was to go down here and look at this, we made this report for both of them. Describe how these participants' pre-weights are related to the mean. That's this information right here. Above the average. Average is a different way of saying mean. So you can say participant number 26 was 1.3 standard deviations above the mean, and participant number 11 was negative 2.65 standard deviations away from the mean, to the left of the mean. So if we were to put some direction in this too, and I think that would be important if we put direction to this, that's pretty much what we're going to be seeing here. Is we have 1 standard deviation and then 2 standard deviations, and this is not of scale, but it's close enough to what it'll look like for this example. This is negative, and this is negative, and this is positive, plus 2 standard deviations. And what we're going to get is we're going to have for participant 11, it's going to be right around here for participant 11, negative 2.65. That's how far it is away from the mean, and the mean is going to be 0. And then participant 26, as we see here, is 1.3. So that's going to be right here. 1.3 standard deviations to the right of the mean. This is 2.65 standard deviations to the left of the mean. Very important distinction, because now we have direction to it, so you can mention that as well. All right. let's go ahead and move on to the next part. So standardize the scores for weight loss, run the descriptive statistics for weight loss, and then Z represents the standardized weight loss. So we're going to run the descriptives for the raw weight loss as well as the standardized weight loss. And then we're going to make a graph, a histogram of this. So let's go ahead and do that. So we're going to go into descriptives again, and then we're going to move this out here. And now we're going to go to post weight loss, because that, my friends, actually, before we do that, if you were to right click here, it would display variable names. And then you can have these variable names instead of looking at this view, which doesn't really give you an accurate representation as if it's cut off. So you can just right click and get on display names here. So I'm going to move this over here because that's the one that we need. And we are going to first standardize it. Now we have standardized weight loss here. And now what we're going to do is go into analyze again. We need the mean and standard deviation. And then we're going to graph a histogram of it and compare the following scores. All right, so let's go into descriptives again. And now we're going to move this Z weight loss because that is the standardized weight loss variable. When the variable is standardized, mean and standard deviation, we don't need these two. Mean, standard deviation are checked off. And then we're going to go ahead and press continue here. Check off of that because you don't need this anymore. And then if we were to look at this handy dandy output, what we see here is Z weight loss. We see a mean of 0, and then we see a standard deviation of 1. For weight loss, the raw weight loss, unstandardized weight loss, we see a mean of 8.4587, which is going to round up to 8.46, and then a standard deviation of 5.61. So we're going to write this in as this answer. So we'll just go into weight loss. And actually, I can't type it on here because the editing feature is off. So I'm going to go into here and then write down this information just so that you can see it more vividly and you can see it in highlight as well. So we're just going to type in this information. And this is going to be weight loss. I probably should pause this first. Okay, so I went ahead and organized this information here. And notice here, yeah, so the mean for unstandardized weight loss is going to be 8.46. Standardization brings the mean to 0 automatically. That's the point of standardization. Standard deviation is 5.61 when it's a raw score, and then it's 1 when it's standardized. Now, the last thing that we want to do is get a graph of this information. We're going to graph it out, and we're going to use a histogram. So we're going to go into descriptives, analyze descriptives, and then go into frequencies. We don't need these variables, so we're going to move them over. And so I'm going to display names again. So we have weight loss and Z weight loss. We're going to go into charts, and we're going to go into histograms. And we're going to go ahead and see what this looks like. We don't need frequency table. Now, as you can see here, the shape really hasn't changed, and it's not going to change. The only thing that's different here is that in one case, the mean is centered at 0, the raw score is 10, and then the standard distributions are going to be 1, 2, and 3, as you see here. But what I did right now is I made a screen capture of both of them, and if we compare the raw score to the standardized score, they look exactly the same here. Okay, the last one was a slight bit of mistake, but as you can see here, they look very similar, and if we were to look at their skewness and kurtosis, it would be the same. So if we go into descriptives, and then go into options, and we type in skewness and kurtosis here, check those off, what we will see is their skewness and kurtosis is going to be the same for Z and for the raw. The statistic value for kurtosis, these two values are the same, and in skewness, these two values are the same. So hopefully this is helpful. I think the last part is a reiteration on the part before, where instead of using the weight loss, you're going to use post-weight and do the same process. And then the last part I would like you to do on your own, and this is, in your own words, how the standardizing score help you better interpret the individual's performance. And this is based off of what I talked about in the first video, and you can also refer to your textbook, but provide some quantitative evidence. And as a reminder, quantitative evidence is anything that you do as a calculation, basically. So we did a lot of calculations in this series, and use your best judgment and answer this question the best way possible. Thank you so much for listening. Talk to you soon.